All right, there's not much to do on this page. Functions. All right, the slope, written as m of a line, is a measure of the steepness of the line, expressed as the ratio of the change in the rise, y values, to the change in the run, x values. So I often write it, this should be total review, the change in y over the change in x, right? So we've got y2 minus y1 over x2 minus x1. Change in just means subtraction, all right? So let's take a look at some example slopes. So a positive slope, it rises left to right. All right, so I'm reading right here. It rises left to right. As x increases, f of x increases. So as we go up 1, we're going right 3. It's positive slope. Negative slope, the line falls left to right. As x increases, fx decreases. The slope of 0, that's a horizontal line. As x increases, y just stays constant, right? 0 divided by 3 is the value of 0. And this last one is an undefined slope. So if I take a look at this, this is not a function, right? And if we look at it, the change in y is the positive 3. And the change in x, it's not changing at all, is 0. And in math, you cannot divide by 0. It's an undefined value. So that vertical line is undefined. So now we have some vocabulary here. The intercepts of a graph refer to the places where the graph crosses the x and the y axis. At the x-intercept, the y value is always 0. So your coordinate is always going to be some number, and the y value is 0. Okay. The y-intercept, the x value is always 0. So you're always going to have, you're always going to have 0 for x, and then the y value is going to be some number. You can see them written as coordinates right there. Let's take a look at an example. All right, so if we look at this, what is the x-intercept? Okay, well, the x-intercept is right there. So that x-intercept is where we have -2, 0, right? That point is -2, 0. What is the y-intercept? Where we hit right here. Oops, excuse me, I'll do that one in blue. Okay, what is that coordinate point there? That's 0, 4. Okay, confirm these using algebra. What? Okay, well, here's the equation. So what I'm going to do, if I'm going to confirm this with algebra, I'm going to write that equation, but I'm going to replace y with 0 when I'm trying to find the x-intercept. Because remember, the x-intercept looks like this. So I'm going to plug 0 in for y. So I've got 2x minus, right, I'm writing this equation right here. I'm going to replace y with 0. So 2x is equal to -4. So x is -2. Hey, look at that. This x-intercept is at -2. It's at -2. It's -2. Okay, the y-intercept is when x is 0. All right, we're going to have the y value. So I have my equation. I'm going to replace x with 0. So I end up with -y is equal to -4. So that means y is 4. Hey, look at that. 4, 4, 4. So that means when x is 0, y is 4. When x is -2, y is 0. All right. So given a linear equation, the slope of a line can also easily be seen if the equation is in slope-intercept form. We know that. We've talked about that in this class already. To write any linear equation in slope-intercept form, solve the equation for y. The slope is the coefficient of x. So my slope, right, is the coefficient of x. And the y-intercept is the constant. So there's my y-intercept. And x and y just stay x and y. Okay, makes sense. So if we go here, we're going to write each equation in slope-intercept form. So we're going to be given a form that's not in slope-intercept form, and we're just going to manipulate it, okay, to get it into that format. And then we're going to state the slope and the y-intercept. So this first equation here, right, we've got y plus 4 equals 3x. So I need to solve the equation for y. I want to get that by itself. So all I need to do is subtract this 4 from both sides, right? Pretty simple. Y is equal to 3x minus 4. So my slope is 3. My y-intercept, I always want to write it as a coordinate point, right? My b value is -4, so 0, -4. Oops. Okay, that was not the problem I wanted. Get rid of that guy. Ooh, this one's a little ugly. So remember, we want to get y by itself. That's the goal here. So I think the first thing I want to do is I want to go ahead and distribute this because there's no parentheses in my y equals mx plus b. So I have y minus 3 is equal to -4 thirds x minus 2. Now I need to get y by itself. So I need to eliminate this 3. So I'm going to get rid of that. So if I add 3 to the left side, I got to obviously add it to the right side. And I'm left with y equals -4 thirds x plus 1. My slope is -4 thirds. And my y-intercept is at 0, 1, right? Because my b value is 1. All right, we got a couple more. Y equals 3. Well, oh, okay. So I'm missing the x component. Y equals, well, I could rewrite it like this, right? If I multiply x by 0, it just goes away. So that must be what happened. So my slope is 0, and my y-intercept is at 0, 3. And think about if we graphed y equals 3. It would be right here, right? If y equals 3. And that has a slope of 0. We talked about that a couple minutes ago. All right. Now we got to get y by itself here. So I got to get rid of that 2x. So I'm going to subtract it over there. Okay, so I have 3y is equal to, I'm going to just commute those terms, put the -2x in front and then the plus 6. And I need to divide by 3. So I have to divide every term by 3. So I'm left with just y, -2 thirds x plus 2. My slope is -2 thirds. My y-intercept is at 2. Done.